ask them to share the screen or something also, in case we can go help them. Like,
Yeah, sure.
it's just.
Also, sir, Dhruv has also joined. So can someone please unmute him?
Oh yeah, yeah, sure. Sorry.
Hi. Yeah, sorry. I just joined to see if Nikhil and Praful were able to join properly.
A very good afternoon to everyone. We have Mr. Nikhil Sonawani with us. He is educational technical evangelist with Math Lab. He did his bachelor's degree in electronics and telecommunication from Vishwakarma Institute of Technology, Pune, and he did his master's degree in biomedical engineering from IIT Bombay. He is specialist. He has technical specialization in teaching and research with MATLAB and Simulink. Welcome, sir.
Thank you, Varinder, for the warm welcome. So should we get started?
Yes, we can get started. Yeah, please. So I see Praful is not here.
Full
Yeah.
will be joining in a bit.
Sure,
As we
sure,
said.
please.
Yeah.
We can start. We can start.
Okay. A very good afternoon to everyone. I'm Nikhil Sonone, as Mr. Varinder just mentioned, and so today's session will be a self-run workshop on MATLAB. So what we would be doing today is, as you have attended the session which Dhruv took in the today morning, so and he also had a a poll after that, like what exactly you're looking forward in this afternoon session. And from that poll, we got to know that most of the people are interested towards the image processing and machine learning on ramps. So what we'll do in this session is we'll help you run through the on-ramp courses that are offered by us. I know that it has been assigned as a homework to most of you, and maybe you can use this time to complete it and discuss the doubts and queries that you have regarding these on-ramp sessions. So as I mentioned, that we'll be just going over these the couple of on ramps, and just to make things clear between us, that this is an interactive session. So please don't expect that that we'll be delivering some content and it's more of a listening kind of a thing. It would be really great if we have a two-way communication while we are solving the questions in on ramps, and it would be really great to answer your questions. So you can ask your questions on chat, and as sir currently mentioned that we can have your mics unmuted, so please raise your hands and then maybe we can stop there and you can ask your queries.
Yeah, students, feel free, start doing the work. We have 2-3 hours with them. So just mention that you want to unmute, get your mic unmuted, and we will unmute you. Okay. And if you want to share your screen and something, we can try to give that permission also.
Okay. So Dhruv, before we start, do you want to add anything here?
Dhruv is, yeah, Dhruv, you can unmute now. You are able. Yeah, sure. Okay. Presenter, no?
Hi.
Oh,
Yeah,
sorry,
thanks for that.
sorry.
Sorry.
Yeah. Uh, sorry,
Yeah, I
Nikhil has
just
to present his share, his screen is shared. So, okay. Yeah.
okay. Yeah, Nikhil, we can see it.
Yeah.
So, Nikhil, we already went over the basic installation and MATLAB and Simulink in the morning.
Okay.
So, if you can please show them the on-ramps page. And I think image processing applies to everyone as well as machine learning, no matter which discipline you're from. So it depends on if you want to pick an alternate on-ramp, I'm sure that would be fine. But Nikhil, do you want to run through the image one first?
Yes, Dhruv, I'll just go through the image processing one first, and then maybe we can see which one to take up next.
Okay, yeah, so please show them the MATLAB Academy
Yeah.
page. And then we
Yeah.
can write them. Thanks. I'll drop out after a while, by the way.
Okay, sure. Thanks, Dhruv. So I'd request everyone, like this website or this link is the place where we have all the on-ramp courses available. So I'll also paste this link in our chat window. Or you can just, if you just Google it, MATLAB Academy, you will find the first option over there. I have just pasted the link. So this is the link, and when you open this page, this is how it will look like. As I have already logged into my in my account, this it's the course that I have taken up. Sorry for. Yeah, so it is showing all the courses that I have already completed or partially completed. But if you haven't, like if you are a new user, I'll just try to open it up in incognito mode. So this is the page that if you'll get to see. And these are the offerings that we have. So there are a lot of options over here. If you are very new to MATLAB and you just want to learn basics of MATLAB, then this on-ramp, MATLAB on-ramp is the place where you should start off with. And similarly, if you are very new to Simulink, you can start off with the Simulink on-ramp. Similarly, we have other on-ramps like machine learning, deep learning, and there is in the field of signal processing as well. So there are a lot of offerings, and these are free for you, and these are approximately of the duration 2 to 3 hours, not more than that. So these cover the very basic parts of that particular area. And we have some other courses which take you into further depth of that area. So these are somewhere around 12 to 14 or 15 hours of courses, so you can go through these courses as well. So you will find all the details of it on this page, and you can just start with the courses that you have interest in. So I'll go to the previous page and start with and I'll open the image processing on RAM. So as you can see that I have just completed 6% of it. So I'm approximately at the same stage where you would be at this point. So when you will have the launch button over here. You can just click on that, and it will take you to the page where it starts off. So this is the page where it will show you all the chapters which are there inside in that particular on-ramp. So if you were to just start as you would be starting off, just you'll be starting at the point where it's the course overview. So when you click on that, it will have a short video of what the on ramp is about, what are its offerings, and what you should be expecting out of it. uh, as we are just starting off, maybe I'll just run over just for one of the on ramps to so that you will have a better idea of
And
it.
welcome to image processing on ramp.
Um,
Images.
I'm just pausing for a bit. Just can someone please confirm if the audio is like the audio of from the
Yes,
video is
it was audible. Yeah, yeah.
okay. Thanks, sir. Thanks a lot.
Are everywhere. In industries from healthcare to transportation, agriculture to retail, space exploration to archaeology, image data are used for monitoring, identification, and discovery. And where there are images, there is image processing. At a high level, image processing is a set of techniques which act on a digital image to modify it or extract information from it. Image processing techniques can be used to adjust contrast, remove noise, or find edges. And by combining multiple techniques, you can design algorithms which perform increasingly complex tasks. In this course, you'll use MATLAB and Image Processing Toolbox to implement a complete image processing workflow. By the end, you'll have built an algorithm which can identify and collect images of receipts from a busy camera roll. You don't need to learn a lot of theory to start doing image processing, but it will help if you know a little bit of MATLAB, just the basics. If you've never used MATLAB before, it's easy to get started, and we recommend you first take MATLAB on-ramp to get you up to speed quickly. This course should take about 2 hours to complete, but you can leave anytime and come back later. Throughout the course, you'll be interacting with a web-based version of MATLAB inside our training environment. It has a slightly different look and feel from MATLAB Online or the desktop version of MATLAB, but don't worry, you're using the exact same MATLAB language. Enjoy the course.
So yeah, with that that overview of what the on ramp is all about, so you might have got to understand that we'll be in this on ramp particularly we'll be playing around with some images of receipts, and we'll be doing some processing on that. So in every on ramp, we will be taking there will be some particular example that we'll be doing all sorts of experiments related to that particular topic which we are doing, and that will help us understand the entire workflow for that particular topic. So in this also for most of the on ramps we'll be using the online version of MATLAB. So it is exactly similar to the desktop version of it. Here it's just and the entire look and feel is almost the same, and we'll be using the same language as well. So nothing changes apart from the fact that this is somewhere on the server, and your internet speed will be the defining factor for if it is a bit slow when you are solving it. So once you are done with the overview of it, then the next stage is like what exactly, even this is showing what exactly the on ramp is about and what would be the workflow over here. So once you go to the next page, it will ask you if you want to go to the next chapter or not. And once you go there, it will have some tasks assigned to you, and it will also have what exactly you need to do. So there, as you can see, that there is a message being popped up, and when we are seeing the entire workflow of image processing, the uh, part is first part is import over here. So just a second, I think Praful, I think you have raised your hand. And do you want to add anything? I request the organizers to add Praful as well as to the presenters list so that he can unmute himself.
Okay, just a minute. Uh, Varinder, can you do that, or Dharminder, can you do that?
Yes. Yeah, I have the audio privilege now. Yeah. Thanks everyone. Sorry to interrupt in between. Yeah. Please continue, Nikhil.
Yeah, no worries, Praful. Thanks for joining. So
Yeah.
yes, so as I was saying that the first step for the entire image processing workflow is import. So we in this chapter we will be looking at how to import an image into the MATLAB workspace. So here on the left hand side, as you can see that there is a task being mentioned over here, and this part over here is the theory behind that task. So what exactly we need to do, what are the commands that we need to use, and how we are going to. So the syntax and everything is being mentioned over here. The next area in this over here in this light blue part. So here is what exactly you have to do. So if I were to segregate, this is the theory and this is the practical that you need to do. So in this way, you will help. It will help us to gain a better understanding on, and it's like you learn something and you immediately apply onto that. So if you read through this, like it is just saying that IamRead is a function which can be used to import an image, and the image names to be given in this format for that function, and it is stored in a variable named a. And a similar kind of a task, it is being asked to do, like the variable is I, so we need to save the image in the variable I, and the name of the image is img001.jpg. so just let's try to do that and see what happens. So it's just like I equal to, as it is mentioned over here, the syntax, you can just refer to the syntax over here. I am read and the name of the image.
Yeah. So Nikhil, would it be useful if maybe people who are either joined on this WebEx or over YouTube, if they can just put the answers in there in the chat?
Yeah,
Maybe
sure.
we can have them after the following the task 2 and 3. Maybe we can ask them to do that.
Yeah.
And I also see any questions related to this, right? I think we have a couple of questions. So it would be really useful if uh, any general questions in addition to the on-ramp can also be asked right away. So it can be like a sort of interactive session in addition to the on-ramp, which you can also complete at your own pace, right?
Yeah.
Sure. Yeah. All right. Thanks, Nikhil. Sorry to interrupt again. Yeah.
Yeah, no worries at all. Thanks for adding that, Praful. So yes, so as Praful mentioned, like as this is the first task that we are doing, I'll be running over the solution as well. And from the next task, maybe you can post in your answers, and then maybe we can see whether we are on the same page or not. So the first solution for that, this will be we'll be just writing the syntax and trying to load the image into the workspace. Here there are I just like to draw your attention to this as well. So there are three buttons over here: hint, see solution, and reset. So basically when you will be solving this all by your own, or if you are doing any other on ramps at home, if you are stuck somewhere, or if you are not able to find a solution, you can always go to this option and click on this hint, and there will be some kind of hint given to you, and maybe picking up on that hint, you'll be able to learn what the exact solution is. And if even after that you are not able to get to the solution, you can always click on see solution. So see solution is like the answer key to all the questions over here, and you can just see and understand like what exactly we need to do, and then maybe retry that particular task and do it again. And reset is just reset, it will just clear the answer that you have written. So we have written what the answer for the task 1 over here, and once we are done with it, we'll just click on this submit button. So it will just try to check on what we have done, and as we can see that the test result is correct over here, and whatever we have given as our answer is correct. So once you are done with this, and once you are understood what exactly the flow was here, and you wish to go to the next task, you can click on the next task button here. So it will be the next step for understanding what we are doing in image processing. So we are done with loading images. So what next we need to do? So the next step is just to check whether whatever we have loaded, is it right, or can we visualize it, or can we see that? So this task is about how we can visualize the image that we have saved, and for that we are using the function IamShow. So this is the theory that it is whatever I said right now, it's been written in words. And what the task is right now is to display the image that we have stored in the variable I. So can everyone let me know, or can we have a discussion on this, like what exactly do we need to write in this as an answer to this task?
Yeah, so I can also see some questions on the chat, like, do we have to do this course right now along with you? So it's free for either you can follow by yourself. I think you would need 2 screens if you were to do both. However, what we would aimed for from this interaction was to show what is there, maybe get you started, and also if there are any related questions to these things like reading images, then we can take those on. So yeah, I think people have put in answers, Nikhil. So I can see people
Yeah.
understood. Yeah.
Yeah, and more everyone that I'm seeing over here, the answers over here, everyone is correct. So the command over here is IamShow, and we'll give the variable where we have saved it, and we'll just submit it.
Yeah. So
So there is one more question from Sakshi, that can the on-ramp be done in an installed MATLAB, as GUI as the online version of Simulink seems a bit distorted. So the on-ramps which include Simulink, you can do it with uh, with the installed version of Simulink. That is a local version which you install on your desktop. So there is an option to do that as well. I'm not sure whether all the on ramps which include Simlink have been imported over there. Praful, can you put some light on this?
yeah, I think the Simulink, Simscape on ramps and control design on ramps are something which you can do in the installed version as well. But others are primarily via the website. They are not via the installed version. Mainly to kind of enable some sort of saving your status. So if you leave the on ramp midway, then it's easier to implement it on the website rather than on an installed version. Yeah. So yeah.
Yeah, thanks,
So
Praful.
yeah, so I can see a couple of other questions on the chat as well. Can we take that, Nikhil?
Yeah, sure.
Sure.
Uh,
So
uh, Praful, Dr. Praful, sorry, I could not welcome you earlier. I had another call. So welcome to the session. I think students are really going to enjoy this one-to-one help that you are guys are offering. So yeah, so welcome
sure, sir.
again. Yeah, thank you.
Thank you, sir. So yeah, apologies for the delay from my end in
No,
joining as well. Yeah.
no.
Yeah. So getting to the questions, Rohan is asking, like, we can perform ML and image processing using Python as well. So what exactly is the difference in MATLAB? So MATLAB, when we are talking about MATLAB and Python, like the choice of language depends on a particular individual, I would say, and the offerings that MATLAB has, or as a whole package MATLAB can give you is of the wide range, and that I would say, and uh, uh, Praful, can you is that all, or do you want to add something to that?
Yeah. So I would say that when it comes to machine learning and image processing and using Python or even I can see some questions on OpenCV and image processing using that. So the broad answer is like these functions are there either on OpenCV or on Python or some other platform, right? Based on Python and so on. However, the long and short answer is if these questions are about what should I use when, I would say that use whatever suits your task best. Okay. And if another aspect of this question is why MATLAB, I work for Mathworks, and you can think of my answer as biased. But from my perspective, if you are looking to do something from end to end, say it's an image processing task, if you are looking to do something from, say, importing images or working on a data set, to developing your image processing algorithm, to finally deploying your image processing algorithm on some hardware or onto some other platform. So MATLAB is a platform which lets you do this in the most productive fashion because of the already developed libraries which are there. With others, you might come up with a solution which is like a mix and match of multiple libraries and so on and so forth. So that's my answer of using MATLAB over other platforms. But also, it isn't like this is like a one versus the other question. So if it is not like if you use MATLAB, you cannot use OpenCV or you cannot use Python. So the answer often in the real world is you use what works best. And in a lot of cases, you can use MATLAB plus OpenCV or MATLAB plus Python. All right. So that's like the the longer answers. So.
Yeah.
I can also maybe take on a couple other questions. So I think there's uh, um, there is one from Venkat Sai Praveen, as well as another question from Shaumik, who are asking if image processing functions like IMRead are based on OpenCV. So they are not really based on OpenCV, I will say. So it's not running OpenCV in the background. So IMRead, IMShow, all of these are functions that we have written, but you can integrate OpenCV into this. Yeah. All right. So, okay, some students are unable to access everyone in the chat box. Okay. Yeah. So, in case you can send to even just all the panelists or the so on, I think that would be great. But yeah. Or yeah.
Yeah,
Yeah, Nikhil.
Praful, there is one more question related to can we import codes from other languages like Python to MATLAB? So yes, we can do that. Praful, would you like to add any details to that?
Sure. So in terms of code import, it's not really import code and run it. However, what you can call is you can pass on execution between one and the other. So from MATLAB, you call Python, run Python code. From Python, you can call MATLAB, run MATLAB code. So and then use some way to interface between these. So that is what you can do, and that is what is done in a lot of industry use as well at times. If it's like a hybrid development team of maybe people from computer science as well as people from other core engineering disciplines, then very often we see like this mixed usage as well. All right.
Yeah. Maybe we can move forward with our on ramp, and then maybe we can come back to the questions if they are coming up.
Sure. Yep.
Okay. So as we have done with the task 2 and we saw that whatever we did was correct, we can just proceed to the next task over here. So as you can see that the next task is to develop a robust classification algorithm, and what it is saying is to load another image of the name IMG002 and save it in the as a variable I2. So can everyone just post in what exactly should be the command over here?
Yeah, I think we already have the answers
Yeah,
from
we already
multiple people
had the
here.
answer before I asked it.
Yeah,
So yes.
that's great.
Yeah. So that's
So,
great.
yeah. So in this vein, I think there was a question earlier as well, Nikhil, on what if you had to read multiple images? So Avinash had asked it earlier. So can you maybe outline what can be done if we need to read, if not one or two images, maybe hundreds of images?
Uh,
Uh,
in that case, maybe you can like it if you have it depends on what exactly how what is the format that things are being saved, and if you have it in a particular like it's just the names of the images that have been saved in the folder, and then you want to pull that from, and you already know the names for that, then maybe you can use a for loop for that. Is what one of the options that I can think of right now. uh, Praful, do you have any other options for the doing this?
Yeah. In addition to this, constructing the entire path of using a for loop and so on, an image data store is a good construct for loading multiple images. So, an image data store is simply a pointer. Uh, so you can maybe just give the base folder which contains all the images to this function, and that will essentially help you access all the images in that one by one. And I think we will look at image data store later on in the on ramp as well. So maybe we can proceed to the next question.
Yeah. So I'm just writing the command that you guys told me to the answer to this one. And let's see whether it's right or no. So as you can see that I just had a capital I over here, so it gave me an error. So because the name of the function should be the same as it is, and we cannot modify that, and it is case sensitive. So now you can see that whatever we have done is correct, and then we proceed to the next task. So the next task is about now we have these two images already been stored in our workspace. We just want to display it one after the other, or one at each other's side by side. So for doing that, we can use this function over here. I'm show pair, and a1 and a2 are the variables where we have saved these images, and montage is a keyword where it will show the a1 image on the left and a2 on the right hand side. So let's just try to do that. Uh,
Yeah.
So if you can see on the right hand side over here, the first image, which was this, now is being displayed on the left hand side, and this and another image has been just merged. It's not exactly merged onto it, but when we are displaying it, it's just shown side by side. So so once we are done with this, we'll proceed to the next task. And these in every chapter, when we are going through, when once all the tasks have been done, there will be a section for further practice. So this is an optional thing, and it won't be even if you don't do this, it won't be reflecting on the percentage of what you have completed. But this area is just like good to know or good to work on, so that we'll be getting some more idea or insights about that particular functions over there. So right now, in the interest of time, I'll be moving forward to the next section. Praful, do we have some questions that we can take right now?
No, I wouldn't really say any particular questions here. Some of them I've answered, so maybe we can take on to the
Okay.
next.
So now this is a very short video for what exactly we'll be doing in the next chapter. So let's quickly go over that.
When you bring an image into MATLAB, it's stored as a numeric array. Each pixel corresponds to an element of the array. So the array has the same number of rows as the image's height in pixels and the same number of columns as the image's width. For a grayscale image, the numeric value for a pixel reflects the pixel's intensity and can be any integer from 0 to 255. Dark pixels like these have low intensity values, while bright pixels have high intensity values. Color images are also stored using intensities, but now each pixel has 3 intensity values: red, green, and blue, or RGB values. Each color's intensity values are represented by a 2D matrix called a color plane. So even though the picture is 2-dimensional, it's stored as a 3-dimensional array. When you view a color plane, it's displayed in grayscale. That's because it's a 2D matrix of intensities, just like a grayscale image. But since you know that this is the red color plane, you know that the bright pixels have a lot of red, and the dark ones don't. The blue color plane is pretty dark, which tells us this image doesn't have much blue in it. This bright patch here, well, it's also bright in the green color plane. The result is a pale blue-green in the color image. Different combinations of RGB values create the different colors you see in a color image.
Yeah. So those color filters definitely look like something like Instagram filters and so on. Yeah.
So what we'll be doing right now is we had the image of a receipt over here, and we'll try to split it in RGB spectrum and see how the image is being stored at the back end. So now it's just like what we did previously. It's asking us to read an image and then display it as I am show using the function I am show. So as you can see that this is the image that we have currently loaded and then we have displayed. So the next task here is many image processing techniques. So it is asking for us to use the size function and understand what exactly is the size parameters of that particular image. So can someone post it in the chat, like what exactly should be the function that or the command that we'll be using over here?
Yeah, that's
That's yeah, there are some answers which are correct over here. Yes, we'll be using the size function, but the entire command should be as they have mentioned that we have to store that image, that answer in a variable named sz. So we'll be using that variable as well.
yeah. While we are on that, any idea on what image formats that you will be working with, or what might be typical image sizes that you will be working with? on your projects and so on? If you could, in addition to that, answer those, that would be great. Right? I can see JPEG, PNG, yeah, GIF. All right. Yeah. That's great, everyone. Thanks for all these answers. And thanks for the image answers about the image size as well. So Rohan says the sizes won't be large, I guess. Yeah. All right. Maybe a few MBs. Okay. And I'm sure these answers will evolve as you kind of start working on the projects as well.
Yeah,
Mm,
and just to add to that, like when you will be starting off with a particular on ramp, initially you might feel that it's way too basic or it's way too easy for you. Maybe because you might be knowing some aspects of it. So the on ramps are designed in such a way that a person who is completely new to a topic also can start learning from it, and then as you go into the subsequent chapters of a particular on ramp, the difficulty level of that or the topic will go into much deeper areas of that topic.
yeah.
So yeah, so as we got the answer to be correct, we'll just proceed to the next task. So if you can see that what exactly, if you can just quickly read through what it is asking us to do. uh, uh, it's just asking us extract the red color plane. So in the video also you saw that there will be three planes of for any color image, namely RGB. And so we just want to extract the R part of it, that is the red part of it, and then use IMShow function to display that. So to do that, what we'll do is we'll store the I we'll use the variable R, and we'll just copy the content what is there in the variable I to this variable, and we'll just select a particular plane and neglect the other two planes. So can someone tell or write it in the chat that how can we do that? Yes, there are some. Yes, there is like someone is asking like, will one be for red, two for G, and three for blue? So yes, that will be the thing. So one is for red. So it's in the same order of RGB. So yes, we have got some correct answers over here. So we'll be writing it as I, and so colons over here. Colon means that we are selecting all the available options for that particular parameter. So it's like from one to the end of it or to the last part of it, to the last uh, pixel of it, we are selecting everything. So for so when we are talking about the two-dimension part of it, the pixel intensities, we are selecting everything in x direction, we are selecting everything in y direction, and here the z direction is the plane here. So when we are selecting R, we'll be selecting one here. So let's see what we get. Sorry, I didn't display that. I'll just use the IMShow as well. So if you can see that the R part over here, it's you can see it's in the grayscale over here, but by it may look like it's the where did the red part go from here? But as you also saw in the video that the darker regions over here will be mean that the red intensity is low, and the white region mean that the red intensity is very high over there. So that is how you should be perceiving this. Praful, sorry I interrupted you. Would you like to add anything?
No, Nikhil. So I think there is a question from Aishwarya on if we need all three planes,
Hmm.
then will we need to write three different statements? So yes. So the short answer is yes, you would need all three. You'd need to write three different statements. You can also maybe write a for loop and just vary that from 1, 2, and 3. So you can do that. However, typically in image processing applications, what you will see is you will utilize information in one specific plane and then use that for processing. So yeah. So
Yeah. So I guess that's clear. So we'll proceed to the next task over here. So what exactly is this task asking is it's the theory is explaining what exactly is the uh, unsigned 8-bit integer, and it has the intensity of will be varying from 0 to 255, 255 being the brightest point and 0 being the darkest. And it is also telling us the exactly what does the max function do. So max function will be finding the maximum out of the available array that we have given to this. So can someone post it in the chat window that what should be the answer for this? You can take some time to just go read over this, because I know it's a bit lengthy, and we can then try to solve this.
yeah. In the meantime, Nikhil, while we could get some answers, uh, like any, would RGB be the only sort of images which are there? Can images be of some other sort as well? What do you think? Okay, I think people have started to answer that as well. Uh, so you can mix like two color planes and get just an RG or so on image, and heat map images are in a completely different color map as well. Yeah. All right. Uh, so yes, so the short answer to this is I think you can have a whole variety of images. They need not necessarily be RGB. They might be of other different types as well. So someone had said CMYK, yes, this, and others had said grayscale images, which are like, so all of these are just color maps or color planes. So you can like essentially, if you can map it to some sort of scale, you can read it and reconstruct that image.
Just to add to what Praful mentioned, like when just an analogy to this, when we want to locate a particular point in the three-dimensional space, XYZ axis are not the only available options that with which we can do that. We also have the cylindrical axis and all other types of axes, and with that help, with that also we can achieve to locate a particular point. So this is something similar to that. So RGB is one of the axis, I would say, where we can describe an image. HSV and CMYK are some other types of that as well. So yeah, coming back to the task which we were solving there were a lot of answers, and I'll just write one of that. Like majority of you gave me this answer, and I'll just check whether it's right or wrong by just submitting that. Sorry, it was a comma over here. Yeah. So whatever you guys told me was the right answer, and we have got the answer for that. Someone was asking like, what is the significance of semicolon over here? So semicolon basically executes that particular command, but does not display it at that point of time. So Rmax over here will be saved in the workspace, but as you can see that we are not able to see it uh, in the canvas over here. But if you, when we were doing the task 2, we didn't give semicolon over here, and the answer was immediately displayed here. So I'll just try to remove it, and sorry, I'll just try to submit it again. So you can see that the value of that has been displayed over here.
Mm.
There is a question from Abhi that semicolon comma semicolon, why is that getting R plane? So semicolon dot semicolon is not getting the R plane. Semicolon is just, semicolon means that all available options for that basic that parameter. So if I were to write this as X parameter, this is Y parameter, and this is Z parameter, then semicolon over here will mean all available options in X. And when we are particularly choosing the R plane, this one over here is the deciding factor for that. So if it was 2 over here, then it would have been the blue plane. And if it was sorry, if it was 2 over here, it would have been the green plane. And if it was 3 over here, it would be the blue plane. So similarly, the next task is for the minimum finding the minimum pixel of that. So I'll just as you have already answered this, I'll just copy this over here and just change the function to the respective task. So you can see that if, as I didn't give a semicolon over here, the answer was displayed here. So the minimum value of the pixel in the entire image is 0, and the maximum value is 255. So again, there is some aspect for the further practice. You can revisit this when you will be doing all by your own. So now this section is for converting the images into a grayscale image. So if you see on the in these images, if this is an original image, this original image in turn is comprises of 3 planes, namely red, green, and blue, as we saw right now. So and we need to convert this original image to directly grayscale. So grayscale will be just black and white kind of a image. It won't have 3 planes at all. So it is like it is converting a 3-dimensional image into a 2-dimensional image. Obviously, we'll be losing the color information from this, but at times we might need to work on such kind of images. So we'll be seeing how we can do that. So here also, as we can see that the dimension for this was height into width into 3, and here it's just height into width.
So it would be useful here maybe to understand, like, what do you think? How can we go from RGB planes to a grayscale? Anyone, would you like to take a shot at it? How would, say, how would a pixel in RGB be converted to grayscale? Like, can you describe, uh, not the function, but the
Like maybe some if someone can
the
tell what
mathematics?
exactly we need to have in the RGB to gray function, or what is
Yeah,
happening at the back end.
yeah. What is the mathematics behind it? Uh, anyone want to take a guess? I think. Uh, so Yeah, so I can see a couple of values. I can see some are saying thresholding, some are saying binarizing, some are saying matrix values go from 0 to 255. Okay, it removes color and so on. Yeah, yeah. So essentially, I think some have put in. Abhishek says he has put in like a formula sort of thing. Yeah, all right. Yeah, that's and some others have put in the function. What do you think, Nikhil? Like, how would you maybe put in a mathematical function mapping this RGB plane to gray?
Maybe we can have like all the information from all the three planes and then save it into a particular variable, and then that will be the final plane for that. So that's what comes to my mind in a vaguely.
Yeah. But then if you save all three images and say if there are high values in both R, G, and B, then for the grayscale, the matrix, the sum of all three matrices, the value might go beyond 255, right?
Yeah.
So then to get it back to 255, I think maybe a division by 3 would be useful.
Yes. Yes. Yeah. Definitely. So
So
it's be
yeah,
more of addition and then dividing it by 3. So if it, for example, if all the three planes had 255 as the value, so in the grayscale part also it will be 255 into 3, like the addition of that and then dividing it by 3, and that will be the the brighter spot on the grayscale as well. Praful, am I right? Can you please confirm on that?
yeah, yeah. I think you're absolutely correct. So we can simply say do R plus G plus B divided by 3. And so Abhishek, who wrote the formula, like grayscale is 0.299 R plus 0.587. So essentially, if you give equal weights, so 0.33 into R plus 0.33 into G plus 0.33 into B. So that's the same as 1 by 3 into R plus G plus B. Yeah.
Yeah.
So there are other ways of converting, like others who put in thresholding or binarizing. Those are also ways of converting things to a grayscale or to a binary format. But in here, I think the answer that we were looking for is just the conversion. Yeah,
Yeah.
yeah. I think some others had that answer as well, average of the RGB and so on. Yeah.
Yeah. So this task is also asking us to do a similar thing. The only difference over here is we are directly using the function which is available in MATLAB. That is IM to gray. So can someone tell what exactly would be the function? I know it's just writing a function, and I'm troubling you by asking you to write again and again. But maybe that's the only way we can make it more interactive. Yeah, some have given the correct answer over here, so I'll just copy that. Just a second. Due to some reason, I'm not sure why I'm not able to type into this. Can I just unshare my screen and check what exactly is the issue? Praful, meanwhile,
Sure.
can you just take up some questions or uh,
Sure. Sure, Nikhil.
for
I can
that?
do that.
Yeah.
Yeah. So yeah. So yeah, while Nikhil sorts this out, maybe like I've just shared a link to the types of images in the chat. So in addition to RGB images, you can look at working with uh, indexed images or grayscale or even HDR images, like the ones which are captured by our phones and so on. Also, if you are working with something like satellite data, right, you may end up with images which are which give you, instead of RGB color values, values related to different wavelengths which are captured by the satellite camera. So those are called multispectral or hyperspectral images. So uh, they also play an important role in a lot of uh, satellite or a lot of image processing applications. So
Yeah, thanks, Praful, for sharing that info. I guess it's working for me now. I'm able to type.
sure.
So yeah, so as you guys mentioned that we'll be using this command over here, we'll just check if that's working fine or not. So it's giving an error over here. So can someone tell what exactly is the error over here, or why we it's showing it as incorrect? Yeah, exactly. I haven't displayed it. So we need an IM show as well over here. Yeah, so this was the original image over here, and that this is the grayscale version of that image, and now it's we can see that it's being displayed. So similarly, we are trying to do what exactly we did in the previous section. We are trying to find the size of this GS image that we have now created. So I'll just save it the way we did for the previous task.
Yeah, Nikhil, we are also at nearly the hour mark. So maybe after this we can take a short break, take on any questions from others, and then maybe proceed with
Yeah,
some.
sure. Yeah.
Yeah.
So as you can see that we have come to the end of this chapter as well. In the interest of time, maybe what we can do is we'll be stopping over for the image processing on ramp over here, and I think this might have gave you a bit of an understanding on how exactly you need to proceed when you'll be learning something from on ramps. And you have also seen that on ramps are very much self-explanatory. Everything is very well mentioned, and you may or may mostly you may not won't be needing someone's supervision or someone's help at this point to when you are trying to learn using on ramps. So maybe at this point of time we can take a short break of about 5 minutes, and then come back and then then visit some other on ramp and try to solve some task over there.
Yeah. Yeah. So maybe we can take like a 5 minute bio break, and in the meantime, in case any of you have any questions, like please populate them on the chat, and following this we can take up the machine learning on ramp. Yeah. So it's 3:35 right now. We can maybe get back at 3:40. Yeah, please feel free to step away from the computer. It's important to kind of take some time away as well. Thank you. Hi, hi everyone. So, I'll take over for at this point for the machine learning on ramp, and maybe we can go from there. So, Nikhil, let me just maybe take over presentation privileges. Yeah.
Yeah, sure. One more thing, Praful, before we proceed, there is one question on the chat window. Yes, you have. I rightly see that you have answered it. Yeah.
Sure. Sure.
Sorry,
Maybe we
go
can
ahead.
just voice it over. Yeah.
Yeah.
So Rohan was asking if we here in the image processing on ramp, we essentially like narrowed down the image into matrices and then worked on it. Then can we do things the other way around, like construct images from other signals? So as I pointed out on the answer, yes, you can essentially create images or image representations from other signals. You do that across a lot of applications. And say a image given out by a radar is simply a representation of that radar data in an image format. Yeah. So yeah, let me just begin by so I see another question. So Abhi asks, can I change your name on the MATLAB student license? So I think the student license is associated with your email. So maybe if you can change your account, change your name in the account, and then on your Mathworks account, it reflects that way. So sure. So let me go ahead and maybe begin the machine learning on ramp. Yeah. So I think let me just open up the chat on the other side. And yeah. So I hope everyone's back from the break. Can you please indicate that whether you're back just by putting in a yes on the chat, or maybe using the raise hand thing, raise hand functionality, which is okay. That's great. Yeah, I think I can see a lot of yeses. Sure. So some of you have completed the machine learning on ramp. So in case you have, that's great. You can proceed with the others. But or you can stick around, and in case you have any questions on that, we can take those as well. So please feel free. Yeah. So let me just put the on ramp link uh, in the chat window. So yeah. So yeah. In this case, I put the link for the machine learning on ramp in the chat, and let's go ahead and start. I don't think I have done much of it as well, but yeah, let's go ahead and see what we can do. So this is a brief overview of the machine learning on ramp. So we'll look at what machine learning is. We'll look at classification workflows, essentially, which go from mapping a particular input data to a set of particular discrete classes, which is classification. And following that, following looking at the workflow, we'll look at each of the steps in a little detail. So we'll look at importing the data, pre-processing it, looking at some feature engineering, okay, and finally look at some classification models, like going from mapping these features to right. So yeah, let's go ahead and do this. So I'm not sure if I am. Yeah, let me share the computer audio as well. Yeah, let's do that. Yeah. So, Nikhil, can you please confirm if you could hear the audio along with this as well? Sure. Yeah, just a second. I think Nikhil, can you unmute yourself now?
Yes, Praful. Thanks for that.
Sure. All right. I think my audio is not really kind of going through. So maybe let me try this another way. So okay. Yeah, I think instead of that, let me just go ahead and try this. So I'll not go into details here. Let me yeah. So I hope the screen is visible.
Yes, Praful, I can see your screen.
Sure. Great. Yeah. So let's skip the video bit here, and we can directly go to the on ramp. So essentially, let me just skip this and go to next. Okay. And we can just look at the classification workflow. So anyone, if you could give an example for a machine learning problem, which say in a line. So let me put in one example myself in the chat. So okay, someone says OCR. Yeah, that's a machine learning problem wherein you're looking at recognizing digits or characters from a scanned image. Machine learning problem is some decision making. Okay. Object detection. So uh, so so data analysis and conclusion. So diabetics prediction. Okay. Text sentiment prediction. That's great. Yeah. So let's try this the other way around. So say if I have to predict weather, uh, or maybe instead of weather, let me predict temperature for tomorrow. Is this first of all, is this a machine learning problem? If I have to predict temperature for tomorrow based on past temperature data. Okay, yes. Okay, I think we all agree that it's a machine learning problem. What are in so what type of problem is it? Is it a classification problem or is it a regression problem, you would say? Okay, it's a supervised learning problem. Yes. All right, great. So, and it's a regression problem, right? So, to those who are new, I would say, so supervised learning is when we are looking at taking in some known data and mapping it to, and our outputs are also known. Okay, that is supervised learning. So in case of weather prediction or temperature prediction, what is the input data that we are taking in? To those who answered supervised learning, if so, maybe Abhinash, Santosh, sorry to put you on the spot. Maybe can you mention what is the input data for say temperature prediction? Say this can be temperature, wind speed, or weather on previous days. All right. And output is obviously temperature tomorrow, right? All right. Great. And it's a regression problem essentially because we are predicting a value, right? We are not. Instead, if I was predicting whether tomorrow is going to be maybe sunny or cloudy or rainy or windy, would that still be a regression problem? So if tomorrow I predict that it's sunny or okay, I can see some mixed answers. Some say yes. Okay, most of them are you are saying no, and you are also mentioning that it's a classification problem, right? All right. So you're saying that since we are bucketing outputs into like a broad category as sunny, it is classification. That's great. Yeah. So now, like keeping this in mind, let's look at let's begin with the machine learning on ramp, right? So so in addition to like looking at syntax, right? In addition to looking at MATLAB syntax, what is important also to take away from on ramps is the flow in which you should proceed when working on particular projects, or what are the steps to keep in mind. So looking at this broad overview, if you see the image that is there, um, you have, say, uh, uh, the first step is like obviously importing data. So uh, either importing it from a data set or maybe recording data on your own. The next is organizing this data or pre-processing it. So organizing might involve something like file management on your OS, or it might involve some sort of like, post reading some file management or data management there. Pre-processing it. Can you give some examples of pre-processing? Maybe what might some pre-processing examples be if on data? In general, you can assume the data to be some sort of numeric data. What can possible pre-processing things be? Pre-processing steps be? Or anyone from the audience? Okay, some labels and some data. Okay, so maybe creating some labels to data, storing data in a suitable form. All right. Maybe keeping some data and dropping others, like all right. Identifying and handling missing values. Yeah, that's an important one. So maybe if you're acquiring data from a sensor, then very often in the real world, some sensors might get damaged. So you might have data which is missing for some duration. So how do you handle that? You have to account for that as well. Labeling data is, as many of you mentioned, is a task as well. Storing it in suitable form, either as CSV files or so on, or either in a database or so on. So that is important, yes. Uh, uh, Formatting data properly and creating arrays from that. Okay, that is important as well. Yeah. So again, when you talk about data formats, I think that again is a very important decision that you make. You cannot rely on very basic variables as the size of your project grows. Okay, so you will like essentially very soon, once you go from say working on a very small project to, as you even scale it to even like multiple say sensor nodes and so on and so forth, you'll notice that you know you'll notice that uh, you need more complex data types, and you need them to kind of work with your data very well, right? So creating appropriate data types which combine, say, numeric values with character values with some other date time values and so on and so forth is very important. Okay, so that is something that you should also keep in mind when kind of creating your entire planning your entire machine learning project or machine learning as part of your project. All right. Then comes maybe exploring data and engineering features. Okay. So I think this is, as exploring data might be simply looking at data, engineering features. So what might say some features be in case of weather data? Like any ideas? What might some features? So anyone on what features might be there and yeah. So some say like humidity, temperature, wind speed. Yeah. So either you can use these variable values themselves, or you can also do some you can derive other values from this, like say maximum temperature. So taking the maximum temperature during the day, that can be a feature. So rain, yes. So whether rain yes or no, the possibility of rain, or say the percentage probability of rain, right? So in many cases, like now when you search for a weather report on your mobile phone or on the browser, you'll see that it gives a probability of rain, right? So that can be a feature. Humidity values, yes, those can be features themselves. That's great. Following that, you build a model. You build the machine learning model to kind of map this sort of input to a particular set of outputs. You evaluate it, and you do this iteratively so that you achieve the task that you are aiming for. If my task is predicting temperature for tomorrow, I want to be able to predict it accurately. So I iterate on these steps multiple times until I arrive at a good enough model. And then finally, I also need to think about deployment. So in this case, I developed a temperature monitoring or temperature prediction algorithm. But what if I did? Like, what is the use of that algorithm in the real world? So you also need to think about what next after development. So you need to think about, now that you have developed this algorithm to predict temperature, what is the best way for me to give others access to it? All right. And this is where you need to think of, where can I deploy something like this? So you can deploy something like this online via a browser, okay? Or you can share this application with others, or you can even deploy this application on hardware, like on a microcontroller sort of device. Okay. So yeah. I think you kind of give all this. Let's go on to the next step and let's quickly start this. All right. Yeah. So in this case, what we are going to work with is something called handwriting data. So handwriting data is handwritten letters are essentially stored as individual text files, and each file, as you can see, is comma delimited and contains 4 columns: the time, X, Y, and P. So the timestamp, X is the horizontal location of the pen, the vertical location of the pen, and the pressure of the pen itself. Okay, and the timestamp is in milliseconds, and the other variables are in normalized units. So think of, say, the screen as if you divide it into from 0 to 1. then others are in normalized units, and pressure is also in normalized units. All right. So just by understanding this sort of, so this is one way of storing this data, right? So you can think of how the person who collected this data set arranged this themselves, right? So these are like very sensible variables which you can make, which you can understand quite intuitively, that how can I go from these variables to creating a letter, right? To writing a letter. So when working on your own projects, you may need to create data sets like these. So in that case, you need to think of appropriate ways to store this, right? Yeah. So let's look at the questions now. So here it says, this is in something called myfile.xlsx. So if you want to kind of look at what is there, what you can go to home. Okay, it does not give me more information. Let's work with this itself. So essentially, we have to read data from this Excel file, and this is done using a function called read table. So it can import tabular data from either a spreadsheet or a text file and store it into the variable. All right. So in this case, we have to read data from j.text and we have to store it in a variable called letter. So can you please try put in, what can I put in here? If you could just use the chat to put your answers in quickly. Great. So that's correct. Let me just take the answer from there and copy paste this. All right. Yeah, thanks everyone for the answers. So let me just run this without a semicolon and let's see what this looks like. Okay. So you can see the table comes up here. Yeah. There is the timestamp, the X, Y, and the pressure variables. Okay. I can look at the workspace and see what it appears like. So you can see in the workspace what data type it is. It's a table data type, which is a special type of data type. Okay. And inside the table, you have all of these other data types. Okay. So you have your time, X, Y, and P. All right. So, so if I say had put in like a semicolon here, and this did not show up here, what you can also do is you can simply run this and look at observe the output just by hovering over the variable name. Okay. So you can simply hover over the variable name and you can see that it shows the output here. Okay. So you can go ahead and do that. So let's submit. This is correct. We've assigned it correctly and so on. Now, the next thing is, because it's a table data type, you can use the dot notation to access individual variables inside the table. So inside letter, we had time, X, Y, and P, right? So right now, it's asking us to visualize the letter by plotting the X variable on the horizontal axis and Y variable on the vertical axis. Okay. So right now, so you can see how you can access X and Y. So in this case, can you give me maybe the task for accessing this data and plotting it? If you could just maybe give me the values, how I can access this data. So inside letter, I have X, Y, P, and time. I have to visualize the letter simply by plotting the X and Y. Okay, so I have some answers there. Yeah, it says, so letter dot X will give me the X data. letter dot y will give me the y data. And to plot this, I simply can use plot x comma y, right? So I can simply plot these functions itself. Yeah. So I can simply take in the x data and y data and simply plot this. Right? So I can evaluate this. Let's see what it looks like. It will open up a figure window here. Yeah. So someone had a question, what are the symbols that mean when you type in x and y? So maybe you are referring to this symbol, letter.x. So this symbol. So essentially, this is like after I type in letter and put in a dot, this is essentially a prediction. So I can say you can simply I don't need to specify. I can simply type in letter. I can type in the dot and simply press tab and it will give me an autocomplete option. So if you work with any sort of modern code editors or IDEs, this is the same like environment which will take like this. And so that was the symbol that it's part of this table data type. That's what it indicated. All right. All right. Great. Yeah. So as if you have any other questions like these, like please keep them coming. So you can see this is a very badly written J. You can see the J here and the dot somewhat here, right? So, and our task in machine learning will be to classify this, right? So, so with this, you also realize that robustness of the machine learning algorithm is important. So I wouldn't discard this sort of data as written as a badly written J. I would maybe see if I can develop a machine learning model which can even classify this as a J. All right. Yeah. So let me submit. Okay. And let's go. So it's correct. That's great. Let's go on to the next task. So now here you can observe that the axes are different. So one axis is 0.37, starts from 0.375 and goes till 0.415. The other starts from 0.18 and goes till 0.36, right? So we need to, this is due to the how we acquired the data itself. So we may need to kind of, make these equal in some sense. It's again, so for that you can simply type in axis equal as it mentions and simply run this again. So you can see now the badly written J is somewhat nicely written J now, right? And the axis, both the axes are equal right now. Yeah. So what axis equal did was looked at the last figure, which is essentially this plot. So it will only work on the last figure which was there. So if you have any other plots after this, it will work on that plot instead. So you need to be careful when executing functions like these. All right. So yeah. Now let's go ahead and repeat this for the letter M, right? So what can you do here? So you can, what I'll do is maybe simply copy this and see if I can reproduce this here. All right, someone's already written this. Great. Let me copy paste what Sai Praveen mentioned in the chat. So you read table and you plot. and you forgot the access equal bit. Yeah. Let me just maybe. Yeah. So, yeah. So I can see other answers. Mohit has posted an answer as well. That's great. So, one more thing that you need to notice here, you can see like how this appears right now. One more thing you need to notice here is like, we need to give suitable variable names. So this is just a part of good programming practice. So you can see how we read the file names into a variable called letter. The file names, the data themselves had variables called X and Y and so on, right? And the pressure is indicated with the time, with P and so on, right? So you need, so this is again, if you need your code to be readable to others, you need to kind of come up with suitable variable names. Otherwise, uh, after a while of writing code, you may simply forget that what this variable indicate. Okay, so so yeah, yeah. So I think this goes ahead and does this. Okay, it says okay. Now, oh, it's asked me if the letter should be coming from M. So here we've said var instead of letter, so we can simply replace that. So you can see that instead of variable, if I type in letter at one place, it asks me to press Shift Enter to rename all instances. So you can go ahead and simply press Shift Enter, and the later instances where var was present, where variable var was present, it automatically replaces that. All right. So I think this is something that you can look at. Okay. Sure. So while let me submit and see if this works. It does, and it's correct. Yeah. So there are some comments on the chat that when you transfer code to other people, it's easy for them to quickly analyze. Yeah, that's correct. So that's one part of what Live Editor does. So in addition to this rich text which you can provide an explanation of why you did a particular thing. If you did a particular, say, transformation based on some paper, you can possibly look at, specifying that paper link itself here. All right. So you can go ahead and do that so that others know why you did this particular step. All right. Also, how many of you have tried putting in breakpoints in the code? Has anyone tried doing that? So I can see Shomik has tried putting in breakpoints. So anyone who can answer what breakpoints are? Shomik, since maybe you used it, can you just maybe a one-line answer for that? Okay, Mohit says it's to check error. Yeah. Yeah. So, so I think Dhruv might have talked to you earlier in the morning about dividing your code into sections, right? So you can see like each of these is partitioned into different sections which get highlighted. And you can insert new sections using the section break, run a particular section, or run the entire code from beginning to end, right? Yeah, so you use breakpoints to interrupt code execution in between. So for example, let me go ahead and clear all output. And let me just insert a breakpoint here. Okay, so you can see now what the breakpoint, you can simply insert the breakpoint by clicking on the code line number. All right. And if I run this entire script from beginning to end, not using submit or anything, I'm just simply running this from beginning to end. You can see that right now code is paused here. So it has read the letter text j.txt. It has plotted it, but it hasn't executed this function. Okay, and now I can just simply check what are variable values here, and I can debug this. Now, what I can do from this point onwards is I can either continue or I can go step by step. So I can go step. I can even step into the function. So if you have written a function, then you can go step by step inside the function and come back to the main program as well. All right. So let me go step by step. So you can see it executed this. Now it's on to the next. It still hasn't run this the rest of the way. So it equalized the axis, but it hasn't read the letter M yet. So if I press on step again, it will read the letter. And now again, there is all of these things, right? So, and if I press continue, it will go the rest of the way and it will execute the rest of things. Right? So, was there anyone in the audience who wasn't aware of this? It's okay if you weren't aware. And is this useful when evaluating code? Yeah. So, all right, great. So one more thing that you can use here is, yeah, I'm assuming that this is useful, and this is just one part of how you can kind of work with programs and so on. Another thing that you can utilize here is, say, now this is code that I have written to read a particular text file and plot it, right? So what if I want to do this multiple times? So what I can do is I can create a function which combines these three lines. So any idea how I can do that? If I want to create a function from these three lines. So put the code in a variable? No, not exactly. Put it in a loop. Yes, you can put it in a loop to kind of read multiple things. But another way is, so Shomik mentions we can create a function. Okay, right? All right. So you can obviously put in a for loop and do all of that, but I think a function would be a more clean way of doing things. So an easy way to create a function is, so whatever code repeats, right? So this code which is repetitive, you can simply highlight this. You see these options over here called refactor and all of these. You can simply click on refactor and convert to a function or convert to a local function. Okay. So if you yeah. So if you convert to a function, I can specify the function name. So let me specify something called read letter. So it gives me something called read letter, and read letter is this. Okay. And another way is, let me copy this back. Is I can simply use this refactor and convert it to a local function. In which case, I can simply rename the function here itself. The local function appears in the same MLX or the same file, right? While others appear in a separate file, while just a function appears in the separate file. And the name of the file is the same as the function name. All right. So I hope this is useful. So will this be useful to anyone? Like maybe if not right away, then maybe once you start working on projects. Can you please put in a yes or no to kind of? All right. That's good to know. So for now, let me just disable this and let's just go on to the next task. Yeah. So you can put in like something for b.txt and you can go ahead and do that. But yeah. All right. So glad that we found some of this useful. Now, the next thing that we are looking at is correcting units. So the pen positions are obtained in normalized units. However, the tablet used to record this data is not square. So, so essentially, this data was recorded with people just moving their finger on a tablet or maybe a stylus on a tablet, and that data, the tablet itself was not square; it was rectangular. So a vertical distance of 1 corresponds to 10 inches, while the same horizontal corresponds to 15, right? So we need to kind of adjust vertical and horizontal units that way, right? So it needs to map, the horizontal units need to be mapped to 0 to 1.5 instead of 0 to 1, right? So yeah. So in this case, you have your data points x, y, and p in the variable letter. Okay. Now I just need to map the horizontal units, that is x, into the aspect ratio of 1.5. So whatever was going from 0 to 1, I can simply kind of map it to 1.5, right? 0 to 1.5. So what might be the transformation here? Anyone? If you could just put in the answer. So what do I need to change? I need to change letter.x, and what I need to change it from 0 to 1 to 0 to 1.5. How can I do that? You can do that simply by using the matrix notation. So in this case, if you see here, you can simply say, if you put in x is equal to x plus 3, it will add 3 to all the variables. So since here the variables go from 0 to 1, we need to go from 0 to 1.5. So Shomix put in something, x is x into 1.5. So you can go ahead and do that. Let's see if that works. So we need to multiply the values in x variable of the table by the ratio 1.5 and reassign the result back to x. So in this case, will simply be letter.x is letter.x into 1.5. Yeah. So let's see if this works. Yeah. So yeah. So in this case, maybe let's see if let's see a plot here and a plot here again. So you can see x values have been changed. They go beyond 1 now. And if we run this now, you can see how it appears now, right? So earlier it was just this, and now once we adjusted the x, it appears like this, right? So many of you had put in a dot notation. So say something like put in letter.x dot 1.5. So this is like element-wise multiplication. So if you precede any mathematical operator with a dot, that will do element-wise multiplication, which will give the same result in this case. But that is primarily used when you utilize, when you utilize, say, when you multiply arrays, one array with another. So when you multiply, say, letter dot x with letter dot x itself, then maybe something like this might be useful. Okay, the dot notation. But otherwise, a simple multiplication would be used, would be okay. All right, let's see if this is correct. Yeah, Nikhil, anything that you'd like to kind of share at this point? Maybe something that's useful, something I missed out. All right. Yeah. So the results are correct. Sure, let's move on to the next one. Okay. The next thing talks about normalizing time. Okay. So so if you looked at the time values here, right? So the time values right now do not have any physical meaning. Okay. Do not have any physical meaning. So they essentially represent the number of milliseconds. Okay. So if you see time values in the table, they may have values like 10,000 and so on and so forth. So they do not really represent anything. So uh, they represent anything in absolute terms. Like they just simply are relative to wherever the acquisition was. Okay, so they represent the number of milliseconds elapsed from the start of the data collection session. So in this case, it might be difficult to interpret plots over time. All right, so like a more useful time variable might be duration, as it says, since the beginning of the letter. So so whenever we started in time, so maybe map that to time 0 and then plot the rest of it. Okay, so if we say plot time versus x or time versus y, you can see that some people start writing a bit late. Some, when they acquired this data, some data might have been acquired after a delay, right? So we need to not take this delay into account. So we need to kind of remove this and map this start time to 0. So this is a sort of pre-processing step, right? Which we can take on. Right? So in this case, yeah, let me go ahead and maybe clear all output, and let's just run both here. Okay, yeah. So yeah, so right now you can see you can shift the time variable of the letter to start at 0, and how you can do that is simply by subtracting the first value from all elements. Yeah. So if you see the letter variable, so you can see the first value starts at 13,734, right? So if I subtract 13,734 from all of these, then yeah, subtract 13,734 from all of these, I can essentially make this 0 and make all the following variables added on to that, right? So Nikhil, I just had to put away my headset. Can you please confirm if my voice is still clear? And sure, that's great. thanks everyone. So anyone for task 2, how can we make the first variable 0 and yeah. Am I audible now? I'm sorry, my WebEx suddenly started reacting very weirdly, so I had some issues. All right, great. Yeah, thanks everyone. Apologies for the mix-up. Okay. So in this case, I think I'm just simply taking on some answers that you kind of put in. So yeah, so one thing is you can simply go ahead and do this, or so letter.time is the same value minus the first value. So, or otherwise what you can do is you can simply type in, you can either put in 1 or you can put in start. So I think either one should work well. And you can see how the plot appears of time versus the x and time versus y. I think I can, yeah. So yeah, so I see some others have put in some letter time 1:n. So you don't really need the 1:n at times if you are simply doing an operation like this, and that is where the power of the matrix manipulation power of MATLAB comes into play. So you don't need to specify all of these. Okay, and yeah, and we can simply assign it back to letter. And let me submit and see. So we can see how this looks like. And yeah. Right. So now you can see like if this is time versus x and time versus y and how they look like. So in this case, say, so because we are already always moving when writing m, we are always moving from in x, so x increases. But because when writing the peaks for m, our y coordinate keeps changing, this is how the time versus y appears, the second plot. All right. So there's a question from Mohit, would division work in the same way? Yes, if you're dividing by a scalar, that's essentially multiplying by 1 by scalar, right? So say if you're dividing by 2, that's essentially the same as multiplying by 0.5. So this works in the same way. If you're dividing matrices, then that would be a different matter altogether. So you would take, but even that is like relatively simple, I'd say. Okay. Yeah, I think I missed out the divide by 1000. So in this case, let me divide the result by 1000. I think some of you had pointed that out. And let's submit, because we want it to be in milliseconds. So now we have the value in milliseconds. Oh, all right. So, okay, that was the what you are pointing out, Mohit. Okay, yeah. Yeah, thanks for that. Sorry about missing it. Yeah. All right, I think that's what we had. And you can go ahead and look at the next part of it. All right. So again, we are at 4:35. For 4:37, we'll take on a few more minutes, and then maybe you can go ahead and do the rest of these on your own. But we can maybe have a sort of freewheeling Q&A for the rest of the time. So let's look at this these two quick tasks, and then maybe do the Q&A. Would that be useful, or do you want to continue with on-ramp? So if you could just type in Q&A versus on-ramp on the chat. So I think that would be a useful way to kind of see. Continue. Okay, some say reinforcement on-ramp. Okay. Yeah, so maybe reinforcement on-ramp might not be a good point to go right now. Let's continue with this and maybe see if we can take on some questions here. All right. Yeah, let's do the on-ramp. Yeah. So yeah, so right now a feature, now that you have read all of these and you've processed all of these in some way or the other, now we can compute features, right? So one feature is the time taken to write the letter itself. So time taken from beginning to end. Okay. So in this case, the time taken to write something like I will not be the same amount as something taken for the letter M, or the time taken for a O will be definitely lesser than the time taken for a Q, where you have to put in the O as well as the other straight lines in there, right? Yeah. So let's go ahead and look at deriving the time as one of the variables, one of the features, the time taken to write the letter, or the duration taken for writing each letter. Okay. So in this case, your task is to calculate the time taken to write the letter by extracting the last value and storing it in a variable. Now, because we are starting at 0, the duration of the letter is simply the last value. So can you please put in how you can compute the variable dur by taking in the last value of the letter time, a letter dot time column. Answers, anyone? All right. So we've already got some answers on the chat. So essentially, you can simply just type in end, and this will take you to the last value. All right. I can see some of you have multiple of you have the same answers.
That's great. Yeah. Yeah. Please put in answers. Even if someone's answered it before, it's good to know that you are following, and you may have alternate implementations as well. These are single lines, but as you go ahead and combine things. So in this case, duration is something like 0.608, right? Let's go ahead and submit. Look at the next task. Yeah. And get the next task again. So that now the range. So the range returns the values of range of values in an array. So the range is equivalent to max of can you hear me now? I think I was having some WebEx issues. All right, great. Sorry about that. Yeah. So I think some of you have already solved this one. So essentially, looking at the aspect ratio of the letter. So aspect ratio to kind of see is essentially how wide is the letter versus how high is the letter. So in letters like say J, the letter is tall, but it's not as wide. While in say like O, it will be equally wide and tall. While others like M might have the width might be longer than the height, right? So I think some of you, okay, so you can't see the screen. Let me start resharing again. Yeah, I hope this is visible now. Okay, so Nikhil says the screen was visible. Okay, fine. All right. Sure. Okay. So yeah, let me. So I think some of you had put in the aspect ratio values as well. So your aspect ratio is the range in the y direction divided by the range in the x direction. So I can simply let me copy paste some answers from the chat that I kind of saw. And let's see if this is correct. So range in y divided by range in x. Yeah. Let's just evaluate it and see if it gives us some value. So this gives us a value greater than 1. That means its range in y is greater than the range in x. And let's submit and see, which is expected for something like this, right? So yeah, so that's correct. Then let's, yeah. So I hope, so you can see like how you went from taking on something like these XY measurements to taking two different features. One was the duration as well as the aspect ratio, right? So yeah. So at this point, it's almost over an hour since we started. So this interaction is, I think, till 5:30, if I'm correct. Nikhil, any? Would this be till 5:30? Till 6:30? Okay, sure. So in that case, yeah, we can maybe take a quick 5-minute break and then proceed. Yeah, but let's just do this scatter plot first and then go ahead, right? So right now, what we did was we looked at this feature data, and we have computed this feature data, that is the aspect ratio and the duration, for a bunch of characters. Okay, and we have stored it in a mat file. Okay, how you did that is you can write a function for doing that. I already showed you how you can refactor code and do this. So you can explore this separately. But now let's look at what this feature data shows us when plotted on a 2D curve. Okay, so on the curve, what we will be plotting is on maybe the x-axis there will be the aspect ratio, on the y-axis there will be duration, and each of the characters themselves will be these. All right, so let's just use the scatter function to plot the extracted features. All right, so anyone who, if you could just point out how you can do this scatter. What will be the x? Anyone, what will be the x here? Aspect ratio, duration. Okay, so I might just need to extract it from the features table. So features dot aspect ratio, comma, features dot duration. And let's just see how the scatter plot looks. And yeah, this does not contain any character information, but essentially you can see that it groups of, this is like what you call the feature space. You have taken each of your readings and you've plotted your derived features and you plotted the features. So now each of your measurements is in the, this is each of the measurements in your feature space. X and Y are features here. All right. All right. So some of you, I think all of you have gotten the answer correct. And let's just go on to the next one. Now, if we just take on, yeah. So if we just take on these three values, now, if you see here, the feature table, it has these features for three different characters, V, J, and M, right? So there are three different sorts of features here. Now, if we want to kind of differentiate between what letter represents each of those feature points, what we can do is we can use something like a grouped scatter plot, okay, where the grouping is done by coloring each of these points according to the variable. Okay, so in this case, you can see you can use something like G scatter, and what will be the inputs here? All right, some of you already have answers. So as you can see, G scatter has X, Y, which is the same as earlier, and G. G is the grouping variable. The grouping variable here is the character variable, right? So let me just copy X and Y from here. And the grouping variable will be features dot character. Okay. So if I run this, you can see it automatically took on these three categories, J, M, and B. Yeah, thanks for everyone who kind of put in the answers there. And you can see, so J's have, yeah. So maybe let's also assign some values to the X and Y axis. So let's put in X label. So X label is aspect ratio, and Y label is duration, right? So you can see how the aspect yes, I think you can. So a good here now. No, okay. Yeah. I hope this is clear. All right. So now, yeah, I think it just kind of keeps doing this for some reason or the other. Now, if I want to kind of change any of these things, what you can do is you can say maybe look at the function itself, and if you select the function and click on help, it will open up the documentation page on this, and then you can go ahead and look at look at what can be done here. So please note that this is an important aspect. Looking at the documentation is an important aspect of the learning process as well. So because you cannot sit down and learn MATLAB and in its entirety and then go ahead and look at implementing it. You learn as you go. You work on your project, you look at the documentation, search for something you want, and then go ahead, use it, and that's how you learn more. Okay. So in this case, you can see this is the scatter plot by group. Let me just maximize this window. Let's look at, it will just open up another pane. Yeah, let's just look at this. So you can see G scatter. By default, it is this X, Y, and the grouping. But other than that, you can also specify this. If you specify more inputs like color, symbol, and size, you can modify the marker color, the marker symbols, and the marker size. So by default, here it took on circular markers just by changing the marker size, but you can just by changing the marker color. It did not change the marker type, that is all the markers are circular, but you can change that as well. All right. So I hope that answers your question. I think it was Abhi who asked that. Yeah. Yeah. All right. Great. So looking at the documentation and working is a useful thing. So in this case, suppose another thing that you can do is you can simply look at something like, say I want to look at how I can create legends. So you can simply type in legends here. Okay. And then go ahead and use this. Okay. So yeah. So there is one question on how you can access the documentation. So the easiest way to do that would be to look at, say, if you type in the command window, if you open up the command window and type in doc, it will open up the documentation. Okay. Another thing that you can do is you can type in something like help scatter. So this will put up multiple things. So you can do this with any other variable as well. Like, so you can say help plotting. So you can say, so it did not find anything like plotting, but maybe help plot would work. And it gives out everything where you can do this. And then it gives you documentation links for plots as well. Okay. So the documentation link will open up. So help and doc are two things which you can utilize. All right. Great. So yeah. So now you can see, like, how this is grouped here. So J has a high scatter, high aspect ratio, but the time taken is quite low. M has more or less very low aspect ratio and very low time taken, and V is somewhere in between, like almost low aspect ratio or equal aspect ratios, like equal width in X and Y, and the duration is again very low. So classification will essentially aim to draw boundaries between each of these so that you can separate these out into different classes. All right. But you may have something like, this J here, which is something of an outlier, right? These are values which might appear very out there, right? So these will definitely come up from time to time in real life classification problems, and we need to kind of either you can ignore those or accept that this will be misclassified and so on. Okay. So yeah, so let's just go on to the next section. But before we go, maybe we can just take a quick, it's 5 already, maybe just take a quick 5-minute or 10-minute break right now. So let me change this to 10. You've been sitting here for 2.5 hours, so it would be good if you could just maybe take some time. So Hi everyone. I'll just take maybe a minute more. Apologies for this, just to resolve some issues here. So. Hi everyone. Thanks for waiting. So yeah. So if you could just, I hope like the break was good for everyone, and if you could just maybe put in the chat if you're back, that would be great. All right, that's great. Sure. Already here. Okay, great. I hope some of you did take some time off as well to recharge your batteries and so on. So we have a couple of questions, and they can go over a couple of options also. So let's look at a few things. So sure. Yeah, I hope I hope you can hear me fine now, and things are okay. I'm not sure. Great. Yeah, I don't know what the issue is. It's Teams or WebEx just freezes on me at times. So yeah, apologies for that. Great. So there were a couple of questions, primarily on Simscape on-ramp. So let's see if we can run that, and then we can also can help resolve some of the other issues which are coming up. All right. So Um, so let's look at the Simscape on ramp. So in this case, yeah. So so this is essentially talks about simulating physical systems. So before we go back to the machine learning on ramp, we'll just resolve some of these queries which are there. So this will open up in, I think, the installed version of MATLAB. This may not open up online. So if I get started, yeah, let's see. Yeah, so this will be, you can download, okay, you can launch online. So I hope you can see this, see if you can launch this online. So this will open up on MATLAB online, and you can work there and use it for, like, completing the on ramp there. So okay, Mahanch, he says nothing happens after this. Okay, let's just wait to see if this loads. Okay. Yeah, Simscape on ramp is like recently introduced, and till recently it could be done only on the installed version. So this might be an update which is in the works. Yeah, let's just open a new session. Yeah. Okay. Some of you, I'm not sure if the online version has the Simscape on ramp. Let me just check. So let me just stop this. Okay. So this opens up. Okay, finally. Uh, yeah, this will take its own time opening up. So maybe what you can do is on MATLAB Online, open up Simulink, and then try if you can install, like, run it via that. So Simscape on ramp is new, and that's why you may have some issues running this. So for example, let's just click on Simulink. Let's see if this works. Yeah, let me just maybe stop this. Let me see if I can open up a new tab and simply do this. Okay. So can you see my screen, everyone? So let me just maybe stop sharing and reshare. Yeah. So I hope the screen is visible now. So let me just open up the chat. Okay. Yeah. So essentially what you can do is you can look at opening up Simulink, and once you open up Simulink, okay, you have only the Simulink, state flow, control design, and Simscape on ramp here. So you can go ahead and do this. So this might not really be optimized. So there might be issues if you kind of try accessing it from here. So apologies if you're facing issues in that case. So the next best option is like, if you're having trouble using the Simscape on ramp, then simply go ahead and install it, and then you can work with that. Okay. So only 2 versions are present in Simulink. All right. Okay. I think this works. Like, so maybe let's look at, say, Simscape basics, and this is next. Yeah, so this should work right here. Like, sorry, and I can do the on ramp here. So Mahansh, if you could try this and see if you can explore this, that's great. Maybe that would be useful. Okay. So you can see like how this works. It might be a little slow in comparison to the MATLAB on ramp and so on. So you might take a little time. So that's one thing. Okay. So yeah, possibly because of a trial. Okay. So so if you could just write to us. So please write to so to those having issues with Simscape on ramp, like, if you aren't able to find it and so on and so forth, I put in my email as well as Dhruv's email in the chat. So please write to both of us, or either one of us, and we'll see if we can help you get this running. All right. So that is one thing. Yeah. All right. So for the Simulink, for the Simscape on ramps specifically, please do this. Okay. So open up MATLAB Online, go to Simulink, and the on ramps will be right there. Okay. So open up MATLAB Online, click on Simulink, and the on ramps will be right here on the left. Okay. So yeah. If you're accessing a trial, you might not have access. So please get in touch with us, and we'll try and help you resolve this. Okay. So when I clicked on Simulink, if it shows you only just 2 options, state flow and Simulink on ramp, if it does not show the others, it might be that you have a trial. Trial. Yeah, can you hear me now? I hope I'm audible now. All right. All right, great. Yeah, apologies for this. Like, yeah. So I'll just put in my email in the chat. And along with it, I've also put in Dhruv's. So please write to us, and we'll help you resolve any sort of issues which are there. Okay, in case you are not able to access. All right. Sure. So let's just do that. Okay. Now it's 5:30 almost already. So what do you want to do for the next 1 hour? Like, one thing is we can continue with the on ramps, the machine learning on ramp. The other option is we can do a Q&A and resolve any sort of issues. And the third thing, like, so I can see a couple of things as Q&A. So if you could just please vote for one or the other. Okay, many of you are saying on ramps. Oh, sorry, most of you are saying Q&A. All right. A couple of you are saying on ramps. We can continue with those. Okay, sure. So yeah. All right. All right. Sure. So tell you what. So since many of you are saying like, you know, you want to kind of look at on ramps and the others mostly at Q&A. Let's just look at completing this particular section of the on ramp. Say the classification workflow. Following that, I think you'll be able to kind of look at more complex tasks here. And then let's do, after just completing this section 2, we can go ahead and look at maybe the Q&A, right? And then look at answering those. So let's look at the section on building a model. Yeah, let's. It's taking a bit of time at my end. Let me just check my network. Yeah. So we ended here, right? We had a scatter plot which had these variables grouped, right? So as I said, what is classification? You are essentially partitioning this feature space into different groups or different categories just by drawing something like decision boundaries around them. So these boundaries separate one area from the other and divide it into different groups. Okay, so you can divide something like this. You can say draw boundaries like this, which are very non-linear in nature, or you can draw boundaries like this, or you can even draw boundaries like squares here. All right. So there is no one correct way. Each of these you can follow a particular algorithm and get different sort of decision boundaries here. All right. So in this case, what we'll look at is something known as a nearest neighbor classification. So essentially, this classification is take a particular example and classify it as its nearest neighbor. All right. So we can simply use if we say, I don't know if the scatter plot is present here, but say if we take a particular measurement or take a particular input, if its value is closest to the value of j, then classify it as j. If it is closest to the value of v, then classify it as v. If it's closest to the value of m, then classify it as m. Okay, so it's as simple as that. So what you need to do here is simply use a function known as fit kcnn. So in this case, let's do that. Sorry, fit c knn. So fit classifier k nearest neighbors. Okay, and the first input is your data. Okay, and the second is the name of the response variable, as in like what do you want to classify. So in this case, your data is stored in features, and your response variable is, what is the response variable? What is the, if you could answer what the response variable is? Okay, the character is the response variable. So yeah, variable which is used for the prediction. So I can simply put in character. So you can see how a drop down came in automatically, and you can use that, right? So, and the function which will be created out of this is we have to store it in a variable called knn mod. Okay. So we can simply use this and see how it works. Let's run this, and we can see what it looks like. So it says the KNN model is a KNN classification. The predictor names are aspect ratio and duration. So these are predictors, these two, and the response is the third variable, and the rest are like the classes that we need to divide it into a J, M, and B. Okay, and how many number of observations are there? There are 400 so in this case, there are 470 observations, right? So we have classified all of these. Okay. Yeah. So now, but KNN is more dependent on the radius. Yeah. So KNN is dependent on how each of the features appears, or how are the features lying close to each other. So in this case, let's look at G scatter features dot aspect ratio, comma, features dot duration, comma, dot character. Let's see if this. Yeah. So you can see this is the plot which was there, and we did a k nearest neighbors. So now in this case, it created a model from these observations. So essentially, it is creating a model which takes in all of this information, and it's creating one area here, one area here, one area here. It's grouping, it's creating these three groups based on each of these. And okay, so there are a couple of questions on that. So now if you take, say, a new character comes in, and say if it is here, if in the feature space, then it will simply look at which is the nearest group. Okay, and it will look at what are the k, which and which is the nearest group, and based on that, most of it, if most of the nearest members are in this J group, it will classify it as J, and so on. Okay, so there are a couple of questions on the chat asking how is it possible to get a specific radius, and will it be more biased if we select a particular radius? So the idea behind this is like is to the idea behind k nearest neighbors is to essentially look at like essentially look at how many number of variables which are there closer by, and then classify this. Okay, so it doesn't really have like so I hope the voice is clearer now. I think again, just WebEx being WebEx. So yeah, so what I was saying was, let me go ahead and maybe see how we can predict using this model, and then let's try and answer some of the questions which are there. All right. So in this case, uh, so what you need to do when predicting something is simply use the function predict. You can use the model along with the new data point. So in this case, you can give something like predict just a second, everyone. Yeah. So one thing was, so you can simply use the function predict along with the model. So in this case, the KNN model and the new data, right? So in this case, your new data is classifier letter with an aspect ratio of 4 and duration of 1.2. Okay. So in this case, your new data is stored in, has these two values, 4 and 1.2. So let me first put in something called new data dot aspect ratio as 4, new data dot duration as 1.2, and then go ahead and see if this works. Okay, so if I go ahead and do this, let's see what the model puts out. It says, okay, it says it might just be a matrix with 2 columns. So maybe I just need to put in 4, 1.2. And see if that works. Yeah, that worked. So no need to kind of do all of this. Maybe just put in something like this and use it for prediction. Okay. So yeah. Nikhil, can you take over for a little bit here? Would that be possible? Let me see if I can. Yeah. Nikhil, can you check right now?
Hi, Praful. Yeah, am I audible right now?
Yes, yes, you are.
Okay. Just give me a second.
Yeah, let me continue. Let me change the presenter. Yeah. So sorry about doing this midway here. I'm just facing too many issues with this.
Yeah, no worries at all.
Sure. Yeah. So yeah, maybe we can just quickly go over this part of the on ramp and then maybe we can just simply take on questions.
Yeah.
Yeah, Nikhil, can you try sharing?
Just a second, Praful. I'm facing some issues with WebEx.
Sure, sure. So in the meantime, others, if you have any particular questions, yeah. Sure. Nikhil, let me try sharing on my own. Let's see.
Yeah, please, Praful, if you can, if the issue is resolved at your end, that will be great.
Sure. Let me try that. Okay. Sure. Yeah. So apologies for that, everyone. We'll just try and yeah, there's some issue or the other that's coming up. Okay. Let's go ahead and maybe look at resolving some of the questions and see how we can finish this off. Okay. So one thing was yeah, let's finish this. So I hope this task 2 is clear to everyone. Can you just use the chat to answer yes or no? If this was clear, how you could create a model and how you could use the model for a new prediction. Is this clear to everyone? Can you just put in a yes or no? All right. Maybe let me ask this the other way around. Anyone who has issues understanding this? I hope not. Yeah. So let me just go ahead and submit. Okay. So this is something that you can try and resolve on your own. If in case you do not get the answer the first time around, look at the hints, reset the problem, and try and work with that. So no issues there. Okay. Now, this is what let's finish this section and then let me get back to the questions. Okay. So you can see here, right, on the scatter plot. So there is one thing here on there is one thing here wherein you have say a J appearing here, right? Or there are a couple of V's appearing in this region, which is clearly this like dominated by J's, right? So these values are called outliers, and like these can be used to kind of uh, uh, these are obviously, if you use them to kind of classify, it will result in an error. Like this will be classified as maybe M. These two will be possibly classified as a J, even though they are V's, right? So by default, fit KNN like fits a model with K is equal to 1. Like so it will just look at the closest neighbor and assign it to that value. So in this case, the closest neighbor will be something like this. So if you give this as input, then this will I hope it is clearer now. If my voice was cracking earlier. I hope this is clearer. Yes, great. Yeah. So as I was saying, these are outliers, and they will by default a KNN model will just look at the closest neighbor, right? So this will be classified as the same class as this. All right. So this makes the model very sensitive to outliers, right? So new observations which are near outliers. So for example, if say a new observation comes in here, then that observation might be classified as a J, even though it is actually M, right? So in this case, we can look at making this classification less sensitive by increasing the value of K. Okay, so use the most common class from several neighbors which are appearing. Okay, yeah. So this is where what Avinash you were asking earlier on how is it possible to get a specific radius and so on. So instead of looking at a specific radius, you will look at a particular number of variables or number of measurement observations to look at. All right. So yeah. So this is one way of making the model more robust and not as sensitive to outliers. Okay. So in this case, the number of neighbors to look at, we can simply specify this by looking at a property called num neighbors. So how do we get that? You can simply look at the fit cknn documentation. So what I'll do is I'll look at documentation here. So doc fit cknn. Okay, this opens up the online help. So inside each of the such models like k nearest neighbors, so there will be a lot of these values. So in this case, yeah, let me see if I can open this up here. So in each case, you will have to look at the documentation and look at what other variables are there. So these name value pairs. So this is where you can look at. So as you can see, for fit cknn, you can look at the tie breaking algorithm. So if there are two nearest neighbors, then which one do you want to look at? Okay. The next thing is bucket size and maybe class names, misclassification cost, or look at something like say the nearest neighbor search method. So essentially, what distance do you want to look at? You want to look at Euclidean city block, or here is the other variable. So number of nearest neighbors to find. So currently it's 1 by default, but you can give a other value here. All right. So I hope this is clear to everyone. Yeah. So you can simply look at this third task as repeat the commands from the previous two tasks, but use the number of neighbors and change the number of neighbors to 5. So in this case, we'll copy both the previous tasks. And we can say specify as number of neighbors, and specify this as 5. And see if this works. Okay, so now you can see that earlier what came in at say 4 and 2, 4 and 1.2. So 4 and 1.2, which was somewhere close to here. Earlier, what was predicted as V because of these two outliers is now correctly predicted as J. All right. So is this clear to everyone? How the number of neighbors affected this? Can you please use a yes or no to kind of answer? Yeah. All right. So that's great. Yeah. So this is just one classifier method. Okay. What would be useful is like, you were looking at a bunch of these tasks, right? So what would be useful is you can instead look at, there was a couple of questions on whether you can use a k-means algorithm and so on and so forth. So in this case, what you can do is you can look at, maybe starting a MATLAB online instance, and instead of the on-ramp, if you look at this particular in the app section, and inside the app section, you have something called the machine learning and deep learning section. Here you have two apps called classification learner and regression learner. So for regression tasks, you can use regression learner, and for classification tasks, you can use classification learner. Okay, so in this case, you can simply go ahead, and this will give you access to not only a KNN, but a lot of other algorithms to work with. Okay, so you can go ahead and maybe utilize this and try to work with that. Okay, so in this case, let's see if I can open up classification learner, and you can go ahead and see if you can create a new session either from the workspace or from the file. So let me go ahead and maybe load on a variable. So load Fisher Iris. Okay. So in this case, it loads some data set called Fisher Iris. And then I can simply start a new session from the workspace. I can go ahead and see, set up my measurement variable. So in this case, my measurement variable is my data set, and my response variable is from the workspace again, which can be the species which is there. And I can go ahead and select a lot of other options such as validation, so on and so forth, which are a bunch of things which you can look at. Okay. So I'll not go ahead into what each of these is. You can Um, yeah, in this case, you can see it opens up classification learner, and I get to see a scatter plot. So the scatter plot shows some variables or some features which have been measured from these from this data set, and you can see what the scatter plot looks like. And then I can select a bunch of algorithms to work with here. Okay, so I can select a bunch of algorithms here which are there in model type. So you can see if I select model type, it will come on to the drop down. Maybe take a little bit of time here. Yeah. So right now it's selected a fine tree. So it will use the decision tree to kind of do this classification. But other than that, you have access to a bunch of other algorithms as well. All right. Yeah, and this is getting a bit non-responsive, maybe due to internet issues at my end. So if yeah, so maybe at this point we can stop and take on questions. So I think there are two ways that we can do this. So the on ramps, I think the rest of the on ramps you can continue by yourselves. In terms of questions, either you can post them on the chat, I think, which would be good because others can answer. Like we can take them on and prioritize them one by one. Others might have a similar question as well. So we can do that. And in case you have follow-up questions to that, we can see if I can unmute. I can see if I can unmute you from here. So if you could do a raise hand, and then we can have you ask the questions over audio. All right. Sure. So yeah, so let's look at a Q&A. I'm sorry we can't proceed with the on-ramps because I think we are simply having too many tech issues this far into the session. So I think it would be easier to do a Q&A at this point. All right, so I can see a couple of questions which are coming in. So Harshal asks, will machine learning replace SaaS jobs? Just curious. So SaaS is just software as a service. So for example, MATLAB Online is software provided as a service. Okay, so these are two different things. So if you are asking if machine learning will replace a lot of automated jobs like data entry and so on and so forth, it can. To a large extent, it might get advanced enough to replace a lot of these. But it will simply open other frontiers for a lot of other jobs as well. So verifying this data, looking at marking data which is like suspect, which it classified correctly, but maybe with not much a degree of accuracy or with not as much confidence. So those jobs will still be there. So there are a couple of other questions on how is MATLAB useful to work with CAD models from SolidWorks or any other software. Great question. So I don't know if Dhruv highlighted this earlier. He might have. So one thing that you can do is there is something called SimScape multibody. So let me show this via the documentation itself. If I just go to documentation home and okay, so yeah, so or maybe let me see if I can show it via the installed MATLAB. So in this case, yeah. let me type in CAD. So what you can do with 3D models, specifically from SolidWorks or AutoCAD and things like that, is you can bring them into MATLAB, or more specifically, you can bring them into Simulink, and then you can model different how the 3D models work in space as well. So you can go ahead and model linkages. So, and you can go ahead and do that as well. So it's just taking simply too much time for some reason. Yeah, so let me scroll via here instead. So if you look at Simscape multibody, and let's just look at the examples here. So you can see how you can bring in CAD models from outside and link them to different multibody settings here, and create like a model which responds to some equations as well. So you can use this to create something like simple pulleys to like a XY system, to something like, a gear block, or to even like a larger system, like, you can assemble such systems to like to make something like a backhoe, or like a trailer, a tractor trailer, or so on and so forth. So you can look at all of these options. So if you ask specifically as an API, so you can do. So let me see. So if I just type in SolidWorks, so you can see all of these. So install the Simscape multibody link plugin. So this is essentially, you can install it in your CAD application to export your CAD models. Okay. So what this plugin does is you can import your CAD models into the Simscape environment, and then you can like work with that in Simscape and Simulink. So it works with SolidWorks, Autodesk, and a lot of other options as well. Okay. So the other thing is, once you have defined something like this, you can also go ahead and look at animating this. So yeah, you can go ahead and look at 3D animation and all of these blocks as well. So here again, you can work with either models that you have imported, or you can work with like other models as well, which have been built in Simulink itself. Okay. So I hope that answers your question, Mihir. All right. So I'll just put the link to this in the chat. So for example, what you can do is you can simply go ahead, look at the page address, and copy the link. Yeah. Any other questions either on Simulink, Simscape, machine learning, deep learning, or just signal or image processing, or MATLAB or Simulink in general? So it's a lot of information to cover. The on-ramps themselves, if you sit down and you look at details there, every time you do the on-ramp, you'll learn something different. And typically on-ramps are refreshed with every new release. So if something new has been added during that time, you will get it. You will get an option to do that in the new on-ramp as well. So Sakshi is asking, could you suggest a package for the fast Fourier transform? So the fast Fourier transform is actually a function which is part of the signal processing toolbox. So in this case, say if you look at the signal processing toolbox, so the fast Fourier transform is I hope you can hear me right. So Nikhil, can you please confirm if maybe on the chat if you can hear me? Sure. Yeah, it should be better now. Yeah. Yeah, great. So Sakshi, as you were asking, so it's a part of the signal processing toolbox. You can look at the functions. The function is FFT. You can simply utilize it. If you're working with signal processing toolbox on the installed version of MATLAB, you also have a bunch of apps which can help you like easily compute the FFT in using a GUI sort of tool. So on the installed version, you can see under the signal processing section, you have something called the signal analyzer. So here you can simply import signals, compute the FFT, compute the spectrogram, and so on and so forth as well. If you want to work with more complex transforms like wavelets and so on, there's also the wavelet analyzer, which you can work with as well. Or signal multi-resolution analyzer is another thing where you can look at computing this. Right? So I hope that answers your question. There is a question on how much time will each of the on-ramps take. So each on-ramp might take close to 2 to 3 hours, depending upon how comfortable you are with it, with that domain. So more than thinking about how much time it will take, I would say like maybe focus on like the learning bit. So you can go ahead and see that. So that is one thing. All right. So any other questions? Anyone either related to what we covered today, or maybe if you're looking at, you already have some project ideas in mind, if you want to kind of look at that. So till the time some other questions come in, what I can do is I can show you maybe how you can work with the documentation. So searching the documentation and learning by yourself will be a big part of any project that you take on, either during your internship right now or later on when you transition to industry or academia. Like so, in this case, navigating through documentation is an important skill. So I'll take an example for something like FFT itself, right? So let me just type in. So you have the main documentation page here. You can you can look over the various toolboxes which are available here. You can also look over examples, functions, apps, and so on and so forth. All right. So let me do a simple search such as FFT. Okay. So in this case, it will give me a lot of results, right? So now these are what, around 700 results. Now, which do I look at? What I can do is either I can look at maybe functions. So maybe look at, so it will give me an example of a function. So I can simply say, let me open this in a new tab. Another way is to look at existing implementations. So in this case, what I can do is maybe go back, look at examples which use FFT, and then look at relevant examples here. Okay, so in this case, say FFT analysis during simulation, cyclical data with FFT, past spectral density estimates using FFT, and so on. All right. So, so filtering these results, identifying which would be useful results are an important skill which you will develop over time. All right. So again, inside each of the function blocks, so suppose something like FFT, you can look at the various ways a function is implemented. All right. And below each function is an implementation example. So the documentation will have an implementation example with each function. So you can go ahead and look at that. And also, if you scroll down to the very bottom of the documentation, okay, so you will get some a section on references. Okay, so you can either go via the scroll or you can look at this section here. So under references, you'll see there might be research papers that you can read. There might be links that you can visit and you can go ahead and use that. There might be extended capabilities with different functions and also some related functions. So FFT2 is FFT in 2 dimensions or 2D data. Okay. IFFT is inverse fast Fourier transform, and so on and so forth. Okay. So you can use all of these to look at related functions and so on. All right. So Abhi asks, can we use it for Intel processors? As in, I'm assuming, can you like explain the question a little bit, Abhi? Can you? Yeah. If you could just outline the question a little bit more. What exactly do you want to use for Intel processors? Another thing is, so Harshal asked, can you share some resources for autonomous vehicle toolbox? So as I said, the documentation is the best source. So what you can do is simply go to the documentation, go to automated driving toolbox, look at examples. Okay. And you'll see like how to get started, ground truth labeling, scenario simulation, and so on and so forth. So there are a bunch of resources here. All right. Yeah. So that is one thing. Okay, great. Another way I just want to highlight here is you can also visit, say, the Mathworks website. So in this case, let's go to the mathworks.com. You can go and visit either the products page or the solutions page. So under solutions, you can look at, say, different applications or industries, disciplines, or capabilities. So under applications, there is automated driving systems. So if you click on this, you can see like a combination of a lot of automated driving related materials here. So this is an overview page, but in addition to that, you can get options such as say AutoSAR, Misra C, or some other ISO or IEC workflows. And then here on this page, you'll get like access to a lot of other resources. Okay. So in addition to the documentation, you can see like here you get video resources as well as say links to documentation, links to other videos, and say driving scenarios and so on and so forth. So this is like a high level overview which can combine maybe multiple toolboxes and not just one single toolbox. Okay, you can look at reference applications and so on. Right. So this is another way of doing things. So in addition to the documentation, the Mathworks website will be a good resource if you're working on something. So yeah. So Abhi, okay. So you were asking about generating code for Intel processors, like how you want to. Yes, you can go ahead and generate code for Intel, both processors as well as for FPGAs. So if you're working with Altera FPGAs, so again, what I would say is if you visit the Mathworks website and maybe just use the Mathworks search here, maybe type in Intel. Okay. So you'll see that Intel support from embedded coder. So you can generate C or C++ code for Intel CPUs. Intel I hope my voice is clear now. I can visibly tell when WebEx has slowed down. So yeah, so thanks everyone for pointing that out. Yeah. So you can see like as I was saying, you do have support for Intel CPUs, so you can generate embedded code, or you can also generate code for Intel FPGAs or SoC systems. So this hardware support page will be useful for doing that. So you can go ahead and search hardware support. Okay, so let me put the link again in the chat. So if you see here, you can refine by vendor. You can search hardware support. You can define by vendor, and here in this case, let me search by Intel. So a lot of these vendors we work with closely in supporting a lot of hardware, their additional software, and so on and so forth as well. So in this case, you can see how you can generate C, C++ code for ARM or Intel. You can generate HDL code. And yeah, all right. So that's great. Yeah, I'll just take on one more question. So Sakshi says, you want to analyze results given by a pressure transducer. You can observe a lot of spikes, and can you resolve this using MATLAB? All right. Yeah. So, okay. So one way of doing that right away, let me see if I can open this quickly. So although this is not a pressure transducer signal, so this is just a basic signal, like say an ECG. Let me see if I can go ahead and identify this quickly. So yeah. Yeah. I can't find that particular example, but if you're looking at, peak, removing these noises, your best bet would be signal analyzer. You can try out different sorts of filters there, and you can analyze that. Or if you say open up a new live script, so you get like options such as smoothing data or cleaning outliers. So you can maybe treat peaks as outliers and remove those as well. So both of these options will be like good to use. So either you can try this, or you can go ahead and utilize signal analyzer, and you can create a lot of filters in there, and try and filter out the signal. All right. So like be too deep into this, but the documentation page for filtering, if you just type in filter, you should get enough resources there. All right. So yeah. All right. Yeah, I don't see any other questions. Also, we are at 6:29, so it's been almost 4 hours now. So I hope we didn't I hope this wasn't too much for a lot of you. Uh, yeah, so please take your time learning this. You don't have to do this over a day. You can go back, digest it in smaller pieces. All right. Great.
Yeah, fine, Dr. Praful. It was a wonderful, wonderful session. I think students are going to have a lot of uh, good experience or good exposure for things that they can do out of this session. So yeah, I think we can. I think student doesn't have any further questions. What I feel, they are already saying thank you. Am I right?
Sure. Yes, sir. Like I don't see any particular questions at this point. So if that is the case, and anyhow, we'll be following up with dedicated support sessions for later on. So in any case, in case you want to reach out on this, so I'll just again put my as well as Dhruv's email on the chat. I'll also put Nikhil's. Uh, uh, so please reach out to either one of us, and it would be with your issues, and we can help resolve that. Yeah. All right, sir. So it was great, like interacting with the audience. I think this is a really great initiative that you've also taken, and I can see, like, uh, I I can only thank the audience to kind of be for their interaction, which they have kept on throughout. So it was a pleasure
Yeah.
interacting.
Yeah. The students are really doing really good. So, fine. So fine. Thank you, Dr. Praful. So we'll close the session now. And it was really very interesting. And we look forward for further support from you in the next 7 weeks.
Sure, Professor. Yeah. Thank you.
Thank you.
Thank you,
Thank you,
everyone.
Nikhil. Thank you,
Thank you,
Nikhil.
everyone. Thank you, sir.
Yeah. Thank you. Okay. Okay, students, we'll close the session now. For anything else, you can get back by email and queries. So we'll. No. Actually, you mechanical guys don't have to do NVIDIA assignment. It is for computer science majorly, computer science and electrical guys. So you don't have to do NVIDIA. That's too much for you. I think your hair will stand at the end of 7 days. So just chill and then keep working on. Yes, yeah, Ronak. I think you have a special laptop, man. Something or the other is not running your end. So I think get it sorted out within your friends. You have already formed a Discord group. I think you can try to sort it out down there. Yeah, the formats and everything will be shared. Just keep doing work. The formats and everything will be shared soon. Okay. I will get back with Simscape. Give me some time. NVIDIA for chemical, no. NVIDIA chemical console is going to throw lots of problems, so chemical will be busy there majorly. Yeah, Sai Pratyusha. Actually, what I feel the DFMA software was a general engineering tool. Because you guys also have to develop a product like electronics product or electrical product. So I want you to do that exercise just to understand the concept of costing in an engineering project. It will be very interesting if you do that. That's why I even so the computer science guys I have removed that. I think I have removed them from that student list. But otherwise, I think everybody should do that. No, computer science also I have put that in there. I wish everybody should do that because it really explain you in the manufacturing sector the concept of costing. So I wish you should do that. And sir, one assignment mesh size was beyond. Yeah, so can't you do it from with less number of elements? You can you don't have to scale up the system too big. Make a smaller version of it. Try to do it. Okay, fine. So mesh was part of the assignment, so there was almost an assignment. Um, yeah, assignments I'm looking it out. So just wait for the final version for this MATLAB. I'm going to reduce few assignments. So MATLAB, no, mechanical doesn't have 10 assignments as of now. I think I will recheck, but not 10. I'm sure. बाबा वेट ना अभी फाइनल नहीं है वो शीट जस्ट आज का मुझे फाइनल करने दो द नेक्स्ट NVIDIA GPU and all and console I am going to refresh that. 3 for MATLAB, 1 for, so it's only 8 na. Why 4 yeah, 4 questions na, one assignment is 2 questions, that's okay. Yeah, NVIDIA will not be there for mechanical for sure. Okay, fine. Then do it, Ronak. Yeah, MATLAB and Simulink only for mechanical, only MATLAB General and Simulink. Console, I think you should do it because it's a very interesting tool. I will let you know. But then tomorrow morning you are going to get a DASO, the 3D experience login also. Mechanical, sure they are going to hit 10 assignments later on. So yeah, so it's a lot of learning going on for you guys. So please put efforts. NCCFD is not reading cells, tried many times. Uh, is there anyone who is facing the same problem like Anil with NCCFD? Yeah, I think Simscape removed. I will remove that. Sure, it has a problem. Pranit, you are saying me to check ANSYS? I really don't know what to check in that. Yeah, you can leave, please. I'm just handling few of the questions, then I'll stop. Oh yeah, electrical student have to do MATLAB assignments. If not electrical, who then? I have mentioned electrical at many places, yeah. Simscape I can remove, the rest of the things should remain. I'm removing Simscape. I think it is already giving some problems. Just wait. No, why Simulink should need a license? It's already told that it is, so don't work on that once in the online mode probably. No? Make a login there and do everything what as mentioned. Yeah, Simulink is working. Yeah, thank you, Akshay. Guys, we have a lot of things coming up. Please stay together. And I see only 70 are there. We have a workshop from MIT design team, but it's not going to happen first week. But anyway, that will be open for others also to join in the second week through YouTube. That's also a good thing coming up. But yeah, the 3D experience from Dassault system is also one of the best thing that you are going to get exposed to. All the tool chain is what you are going to learn. So yeah, stay there, keep working, and try to finish the work as early as possible. The formats and all I'll share as like say by tomorrow I'll share. Yeah, chemical need to do, just see the table, please. I don't expect these kind of questions from you guys. Please see the table. It's already on the website, like which assignment to be done by whom. That's already mentioned in that Excel, the Google sheet. Okay, I hope a lot of learning is going on. In 1 week, you are going to learn a lot of things, which will be very beneficial. Okay, guys, if you want to leave, you can leave. Then I'll close the session. Is it okay? Any urgent question you can ask still? Yeah, I can see Venkata. Okay, have a nice day. Bye. Yeah, can someone share Discord link? Aryan want to be part of that, so that you guys can talk to each other. So yeah, you have to solve the assignment yourself because we are going to get a log file from your computers also as part of the submission. So be very careful about that. Okay then guys, bye.